So, welcome back. I hope you've had a nice cup of coffee and stretched your legs. So, it's time for us to continue now with a panel talk. I'm happy to introduce again our opening speakers, Robin, Pujan, and Mikael, who will be joining us for this panel talk. And we have also invited Nils Andreasson from the company Divine Robots. And I'm soon going to give you the floor, Nils. There you are. So the idea of this panel talk is that there's still room for you in the audience to ask questions through the chat, so please do. We can't promise that we will answer all your questions here on camera, but hopefully in the chat we can answer your questions later on. The speakers can't see your questions now, so they will have to answer at a later stage when they log on to the webinar, so it's just good to know. Why have we invited Nils? Because in this panel talk, we want to see a little bit how what we're doing within the marine and maritime sector, how does that coincide with what's going on in other sectors? So what's happening if we look at other sectors, and what can they possibly learn from what we're doing, and what can we learn? So Nils's company is working with virtual reality. You're going to introduce it yourself in just a wee while. So we're going to start with hearing some reflections from Nils on what he's heard so far this morning, and then we'll move into a discussion, and I will also address some of the questions in the chat. So that's the idea for this next half hour before we move on to animals as carrying sensors, as I was mentioning before. So Nils, welcome. It's great to have you with us. And do you want to give a short introduction of yourself to start with, and your company, what you're doing?
Sure. Hi, my name is Nils, and I'm joined here to learn, basically. That's a lot of what I do. And it's an absolute privilege to have that as a job, actually. So I'm in way over my head here, so please don't expect any too smart questions regarding the maritime technology stuff. We're working with games, simulations, visualizations, VR, gamification, things like that. And one of the things we worked quite a lot with is wastewater and freshwater simulations and games. And that's kind of why we're moving into this area and trying to see if we can find any use of what we know and can do. So basically, we're trying to see this as we're adding a soft layer on top of the data, if you will. Visualization, simulations, VR is very powerful to get an emotional response if you want to communicate something quickly to somebody. If you consider, and I'm thinking, especially regarding Robin here, I think that your talk, communicating with legislators, politicians, the public, obviously, and students, nonetheless. There's something that we do. We try to grab onto people who actually know something, and we try to be as accurate as possible in the things that we do. We work, besides the wastewater stuff, we work a lot with security stuff and training, which is obviously extremely important that we get the correct data and correct stuff behind what we're doing. And we're adding the emotional layer and the pedagogic layer, if you want, in front of the data that you're supplying. We have no hope of actually becoming experts in the area, but we're hoping of becoming good enough to be intelligent enough to talk to. That's our major goal in joining into this kind of event.
Great, that's great. Thank you, Nils. And I'm thinking, I don't play games really myself, but are there any really cool games right now where you can be underwater that's based on real data? Do you know?
I don't know, actually. I saw one the other day, but I'm not sure how accurate it is. I haven't researched that yet.
Because I think it's interesting what you say, that VR is a really powerful tool to get an emotional response. I'm thinking if we can, based on real data, create a game a game, yeah, I guess a game, that can actually make you experience the underwater world. Because I mean, by training, I'm a marine biologist, so I've seen a little bit of the ocean when I've been diving. But for most people, that's just such an anonymous part of our globe. And I mean, I haven't even seen I don't know, not even a percent, of course, of all the ocean. But what if we could simulate that and show people? And maybe also simulate the problems we have, what it looks like with, for example, marine litter under the surface that we've been mentioning today. Just interesting to hear your thoughts on that. Would that even be
Yeah, I mean,
possible?
yeah, of course. It's extremely powerful, I would say. We have simulations today when you're standing up high up in the air, and people they're too scared to do it if they're afraid of heights. It's an extremely powerful way of simulating, of showing people what things look like and really experience it. And if you do it together with an expert, it's an extremely good example of actually helping, affecting people and communicating to people in a useful way, I would say.
Yeah. Interesting. And
Can I jump in there on
yes,
that?
I was just going to give the word to you, Robin, because I felt that you wanted it. So please go ahead. Yeah.
Thank you. Yeah, no, I think it's fantastic. Exactly as Niels is saying, there's so much potential for this, creating awareness and understanding using these technologies. I was very involved some years back with immersive internet, with Second Life and Open Simulator, which are immersive environments. They're not games, but it is a 3D virtual world where you can immerse yourself in an avatar in such environments. And I was at a lab at Stanford, the Learning Lab, with Jeremy Bailenson, who was using a lot of immersive technologies with the goggles and even, the floor shaking and moving, and you were in the ocean swimming along, with this virtual reality set. But when I was working at Stockholm School of Economics, I had an island within Second Life, and it was an island in the ocean. And we had, you could swim with your avatar. So it wasn't a game, because I think what's interesting is that it doesn't necessarily have to be a game, but how can you create an immersive environment to bring people together to experience and create a shared understanding so that they can solve the problems together. So if we can combine, exactly as Niels is saying, this, real ocean data in situations and really simulate these and then bring together, as we're seeing, maybe it's the policymakers, as Niels is mentioning, and industry and academia together in such a situation to actually enable creating this shared understanding that will facilitate the problem solving, hopefully in a more rapid process, and also just engage, creating enthusiasm. We were hearing, what do you really need? And I think it is about creating that engagement, enthusiasm among many individuals, kids, for example. And this is one way. There were quite a few schools in England that are using this technology to facilitate individuals to get into the ocean, even though it was only a virtual ocean.
Mm-hmm. Yeah, exactly. And so I'm also thinking that for us that have been working with the ocean for a long time, I think many of us have the feeling that ocean is sort of lagging behind when it comes to awareness and sort of being at every people's minds. And I normally say here in the Swedish context, I say when issues raised about the ocean is reaching the back of the milk carton, the milk package, because there's always information on the milk packages in Sweden. When it's reached there, then we know we've sort of reached the general public. And actually, there has been a little bit on the back of the milk carton in the last few years. So I'm very pleased to see that. But why do I say this? Well, I think that there is this awareness journey that we need to make. And I'm thinking with all the technology we have, isn't it now that we should really make sure that people generally, general public gets the feeling for the ocean, not just swimming in it and sailing on it, but actually sort of getting a real sense of what's in there. So this is, of course, a very leading question, but it would just be interesting to hear your reflections on that. It feels like, I mean, the next decade is the decade of ocean science. The UN has declared the decade of ocean science. It would just be interesting to hear all of your views on how can we step that up even more and make people aware of what's going on. Because I think that's part of the problem. We're not it's very difficult to reach out. Just general reflections. Robin, you're in view. I don't know if you want to start, but now I can't hear you. Maybe you're muted.
Sorry, yeah. Yeah, I can start. I think it's extremely interesting. And you mentioned the UN Decade of Ocean Science. I know that there's a big effort in terms of ocean literacy, and they've realized within the UN that they need to have a much more concerted focus on creating on this ocean literacy strategy. So I know right now there's actually a lot of work going on, and there'll probably be something coming out within the next few months related to how governments and organizations can facilitate this ocean literacy. But one of the things that we've found that's helped a lot is getting out on these like platforms, for example, these like the Kaggle platform, the Zooniverse platform, and how can you engage people in it? We also have something on Facebook with the Killer Algae challenge, where Anna Trondheim created a Facebook page where people, if they're out walking and they see algae in the water, they can take a picture and upload it. So how can you actually get the citizens, people involved? There's a project out of the University of San Diego where they're putting sensors on surfboard fins so that you can, you can collect temperature and pH data on the ocean. So I think it's about, being creative and how can we do these bottom-up fun projects and creating, getting people involved through challenges or projects in school or as you say, the back of the milk carton, these types of, get the taxi drivers talking about it. That's another one, right?
Yeah, that's a good one. Yeah, it's a good one. So I'm a public servant, so I never go in a taxi. Anyway, Nils, what are your thoughts on Robin's reflections? I'll soon give the word to you, Poyan and Mikael. But Nils, what do you think?
I honestly think I'm going to stay quiet because I know.
Yeah, but do you think
at this point, I want to learn a lesson.
That's okay.
Yeah.
But do you think this is something you could tap into? I mean, with your you don't have to talk about your own company. I'm just thinking your type of industry. Is there is there an interest in working with more related to the ocean, or why do you think there is? If there is a threshold, why do you think there is a threshold working with the ocean?
I think, is it? I have no idea actually. I'm interested, very interested, because this. I mean, it takes everything that we really would like to do. It's powerful. It's easy to visualize. I get about 1,000 ideas on how to copyright and use the kind of data that you use, both for the public, but also professionally, as in visualizing data for professionals. That's also a possibility. But mainly, we're more focused on the public, I would say. So I think it's really interesting, and I think we have a huge opportunity of trying to do something fun, interesting stuff here.
Thank you, Nils. Mikael, maybe not so much targeting the public and the general knowledge, but Mikael, what do you think? What is there to be learned from other modes of transportation? I'm thinking if you look at the car industry, I know they are. I think they're a bit ahead of shipping, but what do you think when it comes to using AI, digitalization, things like that? That's a very broad question, but just your reflections.
Yeah, broad question, but it's right on point. If I move from our project, I think that it will for sure put more emphasis on working with AI, machine learning for various reasons. It will be a more complex system to actually to tap into the performance potential is more sophisticated now if we move into, for example, in our world, a wind-powered vessel. So I think there will be for sure much bigger need for AI decision support systems, machine learning to just harvest that potential. I think it's one of the, it's sort of, you can't do it really without it, I think.
Yeah. And so I'm getting some questions here for you via the chat. They're quite specific, so but some of them are about do you think the wind profile will be different in other areas of the oceans? That's a little bit the same as the question about the Baltic Sea. But so my own follow-up question from that is, could you use maybe simulations more? Could you use other people's data and simulate what it would be like in a different ocean basin, or you need to collect your own data?
Partly, I'm not sure because I'm not a meteorologist. Difficult to say. But of course, the situation will be different. It will be different depending on the time of year. It will be different depending on where in the world you are. So naturally, that is what we're looking at. I mean, so of course, the more data you have, the more you know. If you're able to process it. But what we're looking at is trying to get that data to help us narrow down our design space a little bit. So what do we need to be able to handle going out there? So it might be a different set of questions as you ask if you ask a meteorologist. You know, what are the conditions? Then the answer we seek may be completely different, even though we base it on the same data.
Yeah, because there's also a question here about extremes. And I guess, you can collect data for quite a few days and weeks and months and still not get those extreme.
Yeah.
And so I guess you'd have to use simulation somehow to calculate some kind of safety margin there.
Yeah, of course. I mean that's what we're doing, not only in this part of the project. If we look at, we're right now performing really interesting model experiments at the SSPA model basin. Actually sailing a model inside in the basin in waves and so on. But even there, you will never find the extremes. So you have to use a combination of measurements of data and simulation. I mean I think that's the only way moving forward. Using the strength that each of those disciplines has to offer and combining that in a clever way.
And do you think looking at cars, for example, I mean, the ocean is such much more hostile environment to be in and much more difficult to measure. And I'm just thinking about the costs here. I mean, is the car industry might be ahead of us, but I guess that's also because there are different types of costs associated with developing technology on land. But do you think, I guess what I'm getting at is, can we learn more looking at other modes of transport, or is it just so specific being in the ocean, collecting data? Because I guess with cars and trucks, we're collecting data all the time with, what are they doing, what are they using in terms of fuel, etc.
But I mean, yeah, it's a very broad question, and it spans so many technology areas, I think. But I mean, we're already doing it in shipping. We collect AIS data, for example, and we have developed algorithms to sort of predict, to detect behavior that is sort of unexpected. For example, a ship departing in a way that you could predict the grounding, for example. So I mean, we're doing it in different ways, I think, in shipping. And I don't have the complete overview, but that I did. So we could always learn from each other. I think probably the car industry can learn from shipping as well, and vice versa.
Yeah, exactly.
And I'm not sure that it's more difficult to collect data in either of those environments.
Okay.
That's not my perception, at least.
Okay. Oh, well, that's interesting to hear. Definitely. So Pujan, I want to move on to you. Just first, if you have any general thoughts on what the other speakers have been saying here.
Well, maybe. I remember we talked about how we can use AI and that type of technology to implement it in capturing data. The thing is that first you need to have the tool to capture data and store it. And within Burview concept, we need as much data as possible because that will make our application smarter and smarter over the next years. So yeah, absolutely. You definitely need that type of technology within the ocean research, and you will see more of it. So we see that in Norway now, that the companies now are investing much more money in AI technology, than before. So it's a reason for that. So the biggest companies now, like Aker, Statoil, or Equinor, and Technip FMC, the largest companies within the subsea field, and the fisheries as well, are now implementing their own departments of AI within their company. So definitely, yeah.
Thank you. So I have a question here that was in the chat a little bit earlier today, but I think it loops us back to what we started off talking about with creating awareness and emotional response. I think was Nils' words, which I will take with me from today. But the question reads like this, and I guess it's primarily to Puyan and Robin, but open for all of you to answer. What would be the incentive for fishermen to collect plastic waste? And can the drone differentiate between plastic waste and fish? We'll start with those two questions. Puyan, if you want to start.
Yeah, I can answer at the last part of it. If you can differentiate between waste and biological mass, of course. Yes, you can. You have to know what type of frequencies those different types of objects let's say like this. When we are out, we know that we have to use high frequencies to detect the fish, the species we are looking for. I never tried to detect plastic on the water, so I can't answer on the response to the system. But you can see a difference. You can see the echo strings from fish versus not fish, but you can't identify if it's garbage, if it's a rock on the bottom, or if it's another thing. Yeah, so still need to work on that. Yeah.
So I'm thinking about the other question here. What would the incentives be to the fishermen? And then I'm also thinking about what you were saying, Nils, about the visualization. Can I just mention very briefly that there is this project in Sweden where fishermen actually educates public officials and vice versa. So that's sort of not with the aid of visualization or AI, but still it's the same sort of idea that we need to learn each other's perspectives and need to sort of show what's there. I mean, the fishermen have one perspective and the public authorities have another perspective. So so if we focus on this question, what could be the incentive for fishermen to collect plastic waste? I mean, I think a lot of fishermen already do and want to do it. But Robin, you have any thoughts on that? Yeah,
I can comment on that.
Yeah.
Today, many ports actually pay for the waste to be taken away. So the fishermen come in, they bring it in, and then the ports pay to get rid of it. So here, is there a way of enabling, of putting a value on this material? And so this is one of the reasons why we're working with Empower, this blockchain organization, because what we're doing is the fishermen can bring it in, it gets stamped, you know, who's brought it in, the quantity, etc. And then when it's sold, then you can have this feedback back to the fishermen. But I think there's also another incentive where if we combine the data, for example, the drones mapping, so you're a small, medium-sized fisherman, and the BirdView drone is out there mapping the sea, looking for the fish that potentially, if you want to get real-time data, that maybe you could exchange this ocean waste for getting real-time data. So therefore, they're out there collecting the waste, and then they can exchange for the real-time data being provided by the BirdView system. That could be one example. So I think we have to think also creatively around how we can create incentives. What is it that drives the fishermen? Is it cheaper access to fuel, or better access to fish data, or the ability to sell what they're doing as a resource? So I think we can look into different forms of incentives there. And I think too, one of the big aspects is that many of them understand the relationship between the waste and the ability of the biomass to regenerate itself.
Yeah.
I think in Europe, 50% of the waste is from the fishermen themselves. There is an incentive for them to actually clean up their own waste. So I think there is some aspect of that as well.
Yeah. I'm also thinking of recreational boating and using visualization as a tool of showing, for example, what happens when we have a lot of small boats in a shallow coastal area, limited summer months, because a lot of, not everyone, of course, but a lot of boat owners will say, well, how can that matter, what I let out in the water? And so I think just things like that for sort of educational purposes, it would be really interesting.
That's actually, I just want to comment, that is a huge issue. In fact, this is what we're working on. If you look at the average size of a recreational boat, where 7 meters used to be like the largest, now it's almost the smallest. And it's going from sailboats to power boats and huge engines. So you're talking about all the muddying that's going on, right? Because the propellers are getting in the shallow waters and doing this. You have all the paints and anti-biofouling and lead and copper being put on boats. The scraping, 28,000 tons of 28,000 kilos. I can't remember. 20,000 kilos of every year are released into waters in the EU alone, just from scraping boats against biofouling, which also is a huge issue in terms of reduction of speed. If you have biofouling on your boat, the algae and the other shit, the organisms that grow on the boat, you can reduce your speed by, it was like 50%. It's crazy. So requiring the use of even more fuel. So I think that we really need to educate the recreational boat sector as well.
Because I'm thinking about, my thoughts go to this, engaging people in thinking. I know there's been studies done on what makes people willing to make a change in their own lives, to make a contribution to lessen the effects of climate change. And we need to get engaged. We need to feel something to be willing to make a change in our behavior. And I think, Niels, what your company is doing here can create some really powerful tools in aiding with that. So we've been a little bit all over the place, as you that are Swedish know, a famous royal that said. My feelings might not be all over the place right now, but I'm thinking that our discussions has touched upon a few different subjects. There is one last thing here. I'm quite sure I know the answer, but the question is detailed 3D mapping of Swedish coastal waters available today? I'm not sure us being here now can answer, but I'm pretty sure the answer is no. And the following up comment is, it can also be visualized in games. And so, Niels, I think this is, we'll send this home with you. A game with a 3D avatar of the Swedish coastline to make non-ocean lovers love the ocean.
Yeah, I mean, that's typical, the kind of data that we really love. That's what we're doing right now, actually, is mapping cities out of public data. Because really it isn't very realistic for us to start rebuilding all the cities from scratch in 3D. And if that would be available for the ocean floor as well, that would help immensely, of course, to do that kind of things.
Yeah, great, good to hear. So we're going to wrap up this panel talk. I will just, Mikael, to you say that there are a few quite technical questions in the chat. So when you log on to the webinar, it'd be great if you have time to address those questions in the chat. So any last comments from any of you? Please feel free. Mikael,
Thanks for having us.
Yeah, thank you very much. Very well done. Fascinating to listen to everyone. Thank you.
Yeah.
Thank you very much.
Yeah, great to.
I just like to comment. I think one of the things that I've been hearing is the need to work across boundaries and bring in the data science and emerging technology competence with the domain competence, as you were pointing out, Jessica. You're a marine biologist, and that's where we often see that you have people who want to solve the challenges that come with the data, but they don't have the domain expertise. They don't understand which data we should have, or at what point, how is it real-time data, or how often should it be collected? Which data do we need? And I think that's where we really need to focus, not only on engaging individuals, but also building bridges between the domain knowledge and the technology competence.
Yeah. Great. Agree, I heard there. Great. Thank you. All right, thank you so much, our three opening speakers, and thank you so much, Niels. And we'll be hearing a little bit more from you, Niels, later in the afternoon. Thank you so much.
Well done, Jessica.
Thanks, Robin.
Well done.
See ya. So what, I'm not going to look at that now. I'm just need to get my stuff right here. So what we're going to do now, there's the camera. I'm going to hand over to our next session to my colleagues Christian and Fredrik, who are going to show us a little bit or present our next speakers. That is animals as carriers of the sensor. So please come up, and I will swap places with you.
What do you say about that, Christian? We don't have that much place. Should we use my computer?
Yes. Thank you, Jessica, and welcome all to this session. As researchers, if we don't have any data, what should we do? We could become philosophers, but we try to rely on data when we do our studies. So now we're going to look into have 2 sessions focusing on how we collect data. And the first block before lunch will focus on how we use animals to collect data. So we'll have 2 presentations. And we'll start off directly with the first one. So Gustav and Andreas, are you with us?
Yes, I'm here.
Was it
Yes, I'm here.
both of you? You're very welcome, Gustav and Andreas. I must say that I'm looking forward to see this, since I have actually been, as a volunteer, participating in the project that you are to present. So, Andreas and Gustav, the floor is yours.
Okay, thank you. Good morning, everyone. We're happy to present some of the work that we've been doing, performing tagging of bluefin tuna over the past 4 years. It's a collaborative work of myself, Gustav, and Thomas at SLU, together with our Danish colleagues at DTU in Denmark. So we'll start off by showing a couple of introductory films, and then talk about management of tunas, and then the possibilities of the tagging work. So I think we'll just run the first film straight up. And then we follow up with a second movie. So that was the background to the tuna situation, and we're going to run a movie on the on a release of a bluefin tuna.
All right.
Excellent, thanks. I was trying to follow the presentation through the video system. very short, brief history of Atlantic bluefin tuna. There was a historical fishing for bluefin tuna in Scandinavia until the 1950s. And in the Norwegian parts of the Northeast Atlantic, the fishery ran all the way until 1980s. But changes in environmental status and fishing intensity decreased the stock and retracted the distribution range of bluefin tuna after that. Now, the management of bluefin tuna is in the Atlantic is administered by the ICCAT, the International Commission for the Conservation of Atlantic Tunas. It's an RFMO, a regional fisheries management organization, financed by the United Nations FAO. And what you see here is the part of the convention area. The bluefin tuna management is complicated by the separation of two spawning stocks, which have overlapping adult distributions. So fish spawning and being fished west of the 45th longitude are defined as Western fish or Gulf of Mexico fish. On the other hand, fish spawning and being fished east of the 45th longitude are defined as Eastern or Mediterranean. And their distribution is, of course, not designated by human-made geographical ranges. And we know that there are limited knowledge about the distribution ranges of the different stocks and also negative effects on management due to this lack of knowledge. Many contracting parties work for consensus decisions on management plans and fishing opportunities for tuna. And in any fisheries question, you only need two people to disagree. And change is slow in an organization covering the entire Atlantic with large economic interests and with today 43 contracting parties. During the 1990s and the early 2000s, the status of the Atlantic bluefin tuna plummeted. And in 2007, ICCAT finally agreed on a rebuilding plan. It was revised in 2008, and after a lot of disagreement during that meeting that you see a picture of here, in the years to come, a number of control measures were introduced and fishing opportunities were curbed from 2010, illustrating that change was indeed possible. In 2014 and 2015, there were some unsubstantiated observations of bluefin tuna in Scandinavian waters. But in 2016, feeding schools of fish were sighted and documented as a sign of a rebuilding and distributing stock. The overall aim of this project is to describe behavioral migration patterns in relation to environmental cues. Bluefin tuna gives us a fantastic shot at doing this. Most, if not all, of the fish visiting Scandinavian waters spawn in the Mediterranean and then return to Scandinavian waters in late summer to feed. Here you can see the genetic heritage of fish sampled in these different regions, illustrating the east and the west. The orange is eastern fish. On the way to the Mediterranean and back, they make large number of decisions and choices of migration and activity. The overlap between these two stocks in certain areas is large. But we've this far just scraped the surface, and we have much more to discover about these amazing fish. We know that the herring fishery was weak in Skagerrak and the North Sea after the 1950s and 60s. The last time bluefin tuna disappeared from Scandinavian waters, this was a part of that reason. Since 2014, the stock of herring and mackerel have been strong, possibly attracting large individuals of tuna that have the energetic capability of swimming these long distances. And this is why we use bluefin tuna for tagging in Scandinavian waters. Fisheries management was finally successful. It's a reappearing stock in Scandinavian waters. It's a spectacular species with unique adaptations, like being warm-blooded, for example. There's still weak knowledge despite a long history of research. And new possible questions follow new technology. Also, there are undocumented effects on local ecosystems and fisheries. So it's a formidable study species with very demanding logistics. And with that, I leave it to Gustav. I'll just stop sharing.
All right, thank you, Andreas. See if I can share my screen here. Can you see my presentation now?
Gustav.
Right. Yes. Thank you, Andreas. Demanding logistics indeed. So, as Andreas mentioned, we want to know more about the behavior, the migration, and the survival of this new fish that has entered Swedish waters and Scandinavian waters. And technology is where we go to. So historically, this kind of data has been collected by tagging the fish with small plastic or metallic tags, which basically had the address and phone number to the researcher, and then just rely on the fishermen and the general public to catch the fish and then report back to the researcher. And over the decades, this kind of data has really greatly improved our understanding of marine life migration. But of course, the spatial and temporal resolution on this kind of data is very limited, as well as like being reliant on fishermen and the problem with reporting bias and all that. So we really need technological solutions here. So tracking fish using transmitters has always been way more challenging than tracking terrestrial animals. And I've always been very jealous on my colleagues tracking moose and brown bears and stuff, which just attach a GPS transmitter on the animal and then just chill and lay down in the sofa and get this amazing, fantastic positional data streamed right into their computer. We can't really do that in underwater because the satellite technology doesn't really transmit. So we have to be more innovative. So when we track the bluefin tuna here in Skagerrak, we turn to two different kinds of technologies. And the first one is called pop-up satellite archival tags, PSATs. And what we do here is, and here you see on the picture, you see a PSAT tag. And the idea here is that we capture the fish using hook and line. And we do this method just to be able to be selective and to target single individual at a time, which is important when we tag them. The fish is then tagged with a PSAT in between the two dorsal fins. And this PSAT then is programmed to release after about a year. And during this period, the tag will collect sensor data, environmental data on temperature, bathymetry, depth, light levels, and so forth. And after a year, the tag releases from the fish, pops up to the surface, hence the name pop-up, and then transmits its position and also the aggregated sensor data. And using this data, then we can back calculate the most probable track of the fish using existing oceanographic and environmental data as the template. So we're going to see an animation of a bluefin tuna that was tagged with a PSAT in 2017 in Skagerrak. And we would then recreate the migration of this fish using the PSAT sensor data. So as you see, this fish was tagged in mid-September. Straight after tagging, it went up to southern Norway, and then sort of turned around in the British Islands, came down to the Biscaya Bay about a month later, stayed there for approximately 7 months, which we then interpret as important feeding grounds. And then in June, in May-June, which you know is the spawning period for bluefins, it went into the Mediterranean Sea, stayed there for about a month, and then headed straight back out to the Atlantic and up to our part of the world. And that's where the tag popped to the surface and started transmitting the data. So with this kind of data, we can not only just get migration routes, feeding areas, spawning locations and things like that, but we can also get very good spatiotemporal understanding of the mortality of these fish. So this particular fish that we saw here did what we call sort of a full circle. So it returned to where it has been tagged 1 year earlier. I mean, an annual migration cycle. But some of our fish do not do that. And we're slowly starting to get a good understanding of areas of low survival and when and where these fish are exposed to the fishery, for example, which is, of course, very important when we look into management and conservation. And we would very much would like to show you more data here, but unfortunately we are under embargo to talk about our results before we have them published in a proper scientific journal. So please stay tuned there. So that is
to know more. We need to wrap up.
All right. Then I'm just going to say very quickly that the alternative technology. Now I hear myself in an echo. Right. The alternative technology to PSAT is acoustic telemetry. This is an emerging technology that really changing the way we track animals over vast distances in the oceans. I have about 5 more slides, but if we're going to wrap up, I'm going to try to summarize this very, very shortly. So acoustic telemetry, very much cheaper than a PSAT. The PSAT tag could cost about 5,000 euros, acoustic tag about 200 euros. Battery life is incredible for these acoustic tags, about 10 years. So you can actually track almost the entire lifespan of a fish compared to PSATs where the battery life is still quite limited. And also the acoustic tags is very much smaller. You use acoustic hydrophones, you have them here to the right, which is submerged receivers to pick up the ID signals from the acoustic transmitters. Good thing about this is what is happening is that these networks of receivers are popping up.
For a while? Can we get you to hold for a while we connect to our next speaker?
Sure.
So if we can connect to Fabienne, are you online?
Do you hear me?
Yes, we hear you. So we'll quickly switch over to you and let you continue with your presentation, and we'll wrap up with the questions after your presentation as well.
Sorry, which presentation? The one?
Go ahead
before,
with your presentation.
Oh, okay. All right. So. So there you go. So hello everyone. I can see you, but I hope you can. Sorry, I start again. Yes. So yeah, my name is Fabien Roquet. I'm very pleased to present this work here. Thank you very much for inviting me. So I'm a professor in physical oceanography at the Department of Marine Sciences. And here I will talk about the work I've been doing with an international team on tagging elephant seals to get oceanographic data in the Southern Ocean. So the Southern Ocean is very important for us physical oceanographer. There's a very large current system called the Antarctic Circumpolar Current. There's also the subpolar regions that are very important for climate. But unfortunately, it is also a place in the world that is very hard to reach. It is a very bad climate. It's far away from any inhabited region. So that's in that context that about 15 years ago started a project. So to use animals which are living there to get observations on both the environment, the physical environment, and the animals themselves, their foraging strategies, and so to better understand how they live at sea. And so there was this tag that you can see here. It's CTD SRDL. So for CTD means conductivity, temperature, depth. It's really the basic tool in physical oceanography. And it's miniaturized here and put on a logger, which is communicating with satellite And so we can get observation. And the general idea is just as you would think. So we attached instrument on animals, so in particular on southern elephant seals that have been used a lot in the last 15 years because they are both big, so they can cope with this package attached on them. And at the same time, they are really easy to reach on land because they must go back at land twice a year for molting and for reproduction. And so once they're at sea, they dive continuously. They're actually impressive divers. They dive between 50 and 100 times per day. They spend more than 90% of their time at sea underwater. And they can reach on every day easily 500 meter, and the record that we have gotten is 2,000 meter depth. And so when they go back at the surface, then the logger will automatically start to sample to record the properties. So, and in particular, from there we can get profiles of temperature and salinity, from which you can deduce the density of water. So here it's a short animation. So it's not an actual year. It's all the years that we had until 2018 put together. So you can see the distribution of the animals that were equipped over time and get a seasonal view of how we sampled the Southern Ocean thanks to this technology. So right now in our database, we have how many actually? 1,500 tags, I think. So it has grown quite big. No, so I don't need. Well, you can see it again. The color is for the sea surface temperature that we get with the data, but we get also data at depth. That's actually the most important part of this project. And you see, yes. So here I focused on elephant seals, but in fact, there's been animals equipped with the same instrument all over the world. So in particular in subpolar regions. And here you can see the distribution of all the data that are currently publicly available. So in the so-called MEOP CTD database that I maintain and distribute. So there are actually a bit more data now. You can see with the color coding the international nature of this project. And the data can be obtained on the website meop.net. So I invite you to go there and have a look if you're interested. And just for comparison, you can see on the left here, each curve gives you the number of profiles that are available per degree latitude for 3 major data sources. So MEOP is the animal tagging in blue, and then Argo, the floats, and in red these are the shipborne CTDs. And so what we can see in particular is that these 3 sources of data are very complementary. So Argo provides the bulk of data in the large scale. It has been a revolution for the community. But there are regions where Argo has great difficulty to go, and it's in particular in the Southern Ocean. You can see that in fact south of 60 South, the primary source of information that we have nowadays comes from MEOP, comes from the elephant seals mainly. So here is the data portal. Oh, there are some bugs here with the slide, sorry. So I just wanted to point out, and for some reason it's not showing, that the data that we obtain from satellite transmission are actually heavily compressed. So that's one of the issue of this approach. So whenever it's possible, we try to get the tags back on the field. And if we do so, then we get access to all the archive data sets, which is a lot more. So it's basically on average 4 profiles per day over the entire period, and at full resolution, which is a half hertz, the sampling rate. And here what you can see on this slide, it's even more. It's when you put the tag in continuous recording mode, which we've done for a few seals. So it can be done only on shorter period, but then you get actually 60 to 100 profiles per day. So then it's a quite amazing horizontal resolution, and you can see quite clearly in this section here, you have the temperature on top and the salinity below. You can see the mesoscale, the submesoscale activity in the form of this filament at depth. So right now we have 29 such data sets, but we hope to increase that. So that brings us to the new development, which is trying to get even more organized internationally. So we have just been accepted at GOOS, at the Global Ocean Observing System, as a new network that is called Hannibal Born Ocean Sensors. So you're actually among the very first to see about it and to see this logo that has been designed crafted in the last couple of weeks. So yes, as I said, this project is both about knowing better the physical environment for research and forecasting application, and also, of course, to learn more about the animals, to have better data, to improve maybe conservation, we hope, and better understand how they respond to climate change. So the vision of Anibos is to enhance understanding and describe our changing oceans through the eyes of marine animals. And yeah, with this, I will just stop here and take your questions. Thank you very much.
Thank you. So now we allow questions. We have had a few questions here from the Q&A. Fredrik, would you like to take the first one?
Yeah, to Gustav, I think. Has there existed a spawning stock of bluefin tuna in Scandinavian waters?
Can you hear me?
Yes, we hear you.
I think maybe you, Andreas, is the one to answer that particular question.
No, there's some dispute about the extent of the different spawning areas, but bluefin tuna has never spawned in Scandinavian waters. They have always been seasonal visitors.
I have another question regarding the data that is collected from the tunas. Could it be used in any other way than just for tuna management?
I can just say something about this. So I had a few slides which I didn't have time to go through, but the acoustic receiver infrastructure that we're now building, all for the tunas in Skagerrak, but also in the Danish Straits, Öresund, and starting to get into the Baltic. That infrastructure is not for tuna only, it's for all kinds of fish. So the tracking infrastructure is there, but if that is what you're referring to.
And the data that is collected, do you see any other use of it than for fish management?
Similar to the elephant seals, we could make use of these tunas to actually collect data that we need, temperature data and things like that is quite easy to reuse for sure.
I can comment on that. So there's a huge project in the Pacific sector using tuna. By Barbara Bloch is the PI. So it's been attempted and it does work to a certain extent. Now, one issue is the location, the geolocation of the profiles. So we cannot really track these animals as long as they are below water, and it is very important when you have profiles to get location. So they worked a lot in trying to use, in particular, you can use the day, like when they have sunset, sunrise timing, and to assess latitude, longitude, and you can use temperature to refine this. But still, you come up with some pretty large uncertainty in location, so that's a limiting factor still now.
Okay, thank you. I think it's time to wrap up this session for the first of our 2 blocks on how to collect data. And after the lunch break, we'll get back on collecting data without the use of animals. So we'll log off for now, and then we will be back at 1 o'clock. Thank you.